students, myself Devi and Dr. Kiran Yadav. In this session I will discuss about the basics of an amplifier, or I can also call it as transistor amplifier. So let's see first what is an amplifier. Amplifier raises the level of a weak signal. So if we have a weak signal whose amplitude is quite low and we want to make it strong or increase the amplitude, then we can use an amplifier. It does not make any changes in the shape of the wave. It just only amplifies the signal. The shape of the wave remains the same, and there is no change in the frequency of the input signal. Why we need amplification? So the signal is generally the output of a transducer like microphone, thermocouple, and it is very weak. It must be amplified before feeding to the loudspeakers, etc. So consider an example. If you have a mobile and you play a song in it or you play something in it, the audio that can be heard from this mobile is you can listen to that, but if there is a large number of people, then all the people cannot hear that sound from the mobile. So this can be treated as a weak signal if there are a large number of audience which needs to hear this signal. In that case, if you connect this output signal from the mobile as an input to an amplifier, which basically amplifies, like if the sound from the mobile goes into a loudspeaker, and then the output from the loudspeaker or the output sound from the loudspeaker is quite large as compared to the output sound from the mobile. This sound from the loudspeaker can be heard by a very large group of people. So this is basically the amplification process. In this case, we have amplified the sound using a loudspeaker. Clear? So this is the block diagram of an amplifier. We give an input signal to the amplifier which works on a DC supply, and across the load we get an output which is an amplified signal. As we already studied, there are three different configurations in which a transistor works: common base configuration, common emitter configuration, and common collector configuration. And there are three different reasons in which a transistor can be operated, which are cutoff region, active region, and saturation region. So let's see what are these three different reasons. Cutoff region is when emitter junction and collector junction are reverse biased. Active region is when emitter junction is forward biased and collector junction is reverse biased. Saturation region is when emitter junction and collector junction are in forward bias. So both the junctions are in forward bias. This is the circuit of a common emitter amplifier. In case of common emitter amplifier, you can clearly see the polarity of input and output signals have been reversed. Clear? And the output signal is amplified as compared to the input signal. So here the transistor is connected in the common emitter configuration in the amplifier circuits. So this is a common emitter amplifier. So in case of common emitter amplifier, base emitter junction is forward biased by the voltage VBB. Collector base junction is reversed biased by the voltage VCC. During positive half cycle of signal, forward bias is increased, hence base current IB is increased. So collector current IC increases and IC/RC drop increases. The output VCE decreases as VCE is equals to VOC minus RC IC/RC, and there is a phase shift of 180 degree between the input and output. So these are the input waveforms and output waveforms. In case of common emitter amplifier, we can see the input signal. For input signal, the amplitude is small, and for output signal, the amplitude is large. So the wave or the input wave is amplified, and the polarity is also changed or I can also say the phase shift here is 180 degree. Some points about common emitter amplifier. These have moderately low input resistance, moderately high output resistance, high current gain, very high voltage gain, very high power gain. Input and output signals are 180 degree out of phase. This is a comparison of amplifier configurations. There are 3 different amplifiers: common base amplifier, common emitter amplifier, and common collector amplifier. The current gain in common base amplifier is nearly unity, whereas in common emitter amplifier it is high, and in common collector amplifier it is very high. The voltage gain is high in CB configuration, is very high in CE configuration, and is nearly unity in CC configuration. The power gain is high in CB and CE configurations and is low in common collector configurations. Input impedance is low in common base configuration, is high in common emitter configuration, and is very high in common collector configuration. Output impedance is very high in case of common base configuration, is high in common emitter configuration, and is low in common collector configuration. And there is phase reversal or 180 degree phase shift in case of common emitter configuration, but no phase shift in case of common base or common collector configuration. But we studied only about the common emitter configuration in this lecture. Why? Because this common emitter configuration is generally or mostly used in case of amplifier, and now let us see why this configuration is widely used as an amplifier. Because its input and output impedances are suitable in many applications, and it offers current gain, voltage gain, and power gain, all the 3 gains. Okay, so this was the basics about amplifier. So that's all for this session. Thank you, students.